These are the solutions to the 2022 Junior Cycle Maths Mock Paper. Please subscribe to the Untitled Maths YouTube channel by clicking down in the right hand corner. Question 1a. A circular pizza of radius 25 centimeters is cut into equal size slices. Each slice is in the shape of a sector of angle 30 degrees as shown in the diagram. Write down the diameter of the pizza. So diameter is found by multiplying the radius by 2. So the diameter is twice the radius. So I'm going to go 25 times 2, which is 50 centimeters. So my diameter is 50 centimeters. So in a circle, the diameter goes all the way through the center and the radius is halfway the diameter, or from the center to the edge of the circle. How many slices was the pizza cut into? Well, a full circle accounts for 360 degrees and the angle in my sector is 30 degrees. So I basically want to find out how many 30s are in 360, and 360 divided by 30 is giving me 12 slices. Part B. A local pizzeria has a midweek meal deal. The deal offers any pizza with a choice of base, any side order and a drink as shown in the table below. For example, a customer can pick a classic base margherita pizza with a garlic bread and a lemonade. Note that the V is standing for vegetarian. So B part 1, how many different meal deal choices are possible from the pizzeria? So this is basically using our fundamental principle of counting, and that's when we multiply all the different options by each other. So for my pizza, I have 1, 2, 3, 4, 5, 6 options to pick from. For my base, I have classic, whole, Italian and tin, so that's 4. For my side orders, I have 5 possibilities. And for my drinks, I have a sparkling still, a lemonade, a cola and an orange, which is 5 of them. So on my calculator, when I multiply 6 by 4 by 5 by 5, I'm getting 600 possible deal choices. So quite a lot. B part 2. What is the probability that a person orders a pizza suitable for a vegetarian with garlic bread as part of the meal deal? So we have to factor in our vegetarian here. So looking at the menu, I have the vegetarians are margherita, they are vegetable supreme, and this vegan vegetable supreme. So I have 3 choices of pizzas to pick from. So that's my first number to put down. I'm going to multiply it by 3. I then have the base. Well, all 4 bases will suit the vegetarian, so by 4. The person has to pick garlic bread, so I have to multiply it by 1. So there's only one option here for the garlic bread for the side orders. And drink-wise, they can pick any drink. So I'm going to multiply that then by the 5 possible drinks. So it's 3 by 4 by 1 by 5 is giving me 60 choices to choose from. But the question is asking for probability. So probability must be a fraction or a decimal. And it's out of 600 meal choices. That's the answer we got from part 1. So probability is found by making a fraction out of 600, and I'm putting my 60 over 600. That's the amount of choices that we have. And if I divide by 10, I get 6 over 60. And I can also divide 6 into 6 will go once, 6 into 60 will go 10. So the probability of a vegan getting a garlic bread as part of the meal deal is 1 in 10, or that can be written as 0.1 if you want, or 10%. And that's the end of question 1. So question 2a, the universal set U contains the 2 sets P and Q. The union of the sets P and Q written as this set notation, P union Q. So part 1 wants us to basically describe what is meant by P union Q in your own words. So there's many different ways we can explain it, but my explanation will be that the union is all of the elements in the sets P and Q. And just make sure maybe state that without repeating an element. So I can't repeat an element. So it's basically all of the elements that are contained within P and Q. So the union is all of the elements in the sets P and Q without repeating an element I should say. Part 2, shade in P union Q. So union again is everything. So I'm shading in all of this region here. So that's my shading in. So P union Q. B part 1 then is asking us to describe these Venn diagrams in set notation form. So the first one here, they've shaded in, just if you can't see it too clearly, this is what's shaded in here. It's this region here, so it's just the C. So basically what's in shaded portion there would be all the elements of C, excluding, so less, A union B. So I'm excluding anything that's in A and B, so A union B. Looking at the next one, the area that's shaded in here is this portion. So first thing I'm going to do is I'm going to take all of A and B, so it's to include A union B, so everything that's A and B, but what I'm going to do is I'm going to exclude anything that's in C. So I want to exclude that yellow portion. So to do that, I have to go less or exclude C. So it's A union B less C. And the final part there, B part 3, wants us to use set notation to describe this portion which is shaded, and it's this region outside of my 3 rings, but inside the universal set. Remember at the top of this question, U was the universal set. So basically, if I was shading in all 3 rings, I would be going A union B union C. So that would be everything included in the yellow, A union B union C, but I want everything that's not that. So I'm using my set notation, the little dash, which means not. So A union B union C complement is how we pronounce that. So everything that is not A union B union C. You could also use universal set notation if you wanted. You could use the universal less A union B union C. So we could also use that. And the final part, question 2, part C, put a tick in the correct box to show which statement is true. And I'm going to put a tick in the first box. Basically what this means is it's asking, are they equal in the first one or not equal in the second one? And the reason why they're equal is basically because for the union of sets, the order that the union takes place doesn't matter. So in other words, that the operation, the order that it takes place in doesn't matter. So all they're doing there is basically moving the brackets. So we have A union B union C. So it doesn't matter if I put the bracket around the A union B or if I put the bracket around the B and the C. It's still going to be what's known as associative. It's the order doesn't matter. So that's all I'm going to state there, is that for union of sets, the order of the operation, what I mean by operation is the union, does not matter. And if you want to state, it's also known as associative. Union of sets is associative. And I think that should be enough to get through part C. Question 3 is the applied arithmetic question. So income tax is deducted at a rate of 20% on the first 35,300 and 40,000 on the balance. Joanne has a gross annual income of 65,000 euro. So I'm just going to draw that on a number line for Joanne. She has a total of 65,000 euro and she has an annual tax credit of that. Work out Joanne's net income tax payable for the year. So let's look at her pay scale again. So up to 65,000, the first 35,300, so we'll draw a line around here, is taxed at 20%. So I basically need to find 20% of 35,300. So that's the first thing I need to do. So I'm just going to put a little yellow beside that. That's everything here. I then need to find 40% tax on the remainder, which is from 35,300 up to the 65,000. So I'm going to just put a little dash here. So I need to find 40% of the remainder. Now the remainder is found by taking the 35,300 away from the 65,000 euro. And when we take them away, I get 29,700. So I'm basically finding 40% of 29,700. And I'm going to go to my calculator and find those two percentages. So I'm dividing 35,300 by 100 and then multiplying it by 20, which is 7,060 euro. I could also just multiply it by 0.2, so that's what I'm going to do for the next one. So my next one is 29,700 multiplied by 0.4, which is 11,880 euro. I'm going to add those two figures together. So 11,880 plus 7,060 is getting me 18,940 euro. That's Joanne's gross tax. But in order to get her net tax, I need to take away the tax credit because the tax credit is good. So I go 18,940. I'm just going to put a little note there that that's the gross tax. I'm then going to subtract from that the tax credit of 3,545, which is given to us in the question. And when I take that away, I'm getting my net tax of 15,395 euros. So that's my net tax, or Joanne's net tax. And that should be my answer to part A. Looking at part B, Joanne also pays a total of 5,750 in PRSI, pay related social insurance, USC, universal social charge, and pension contributions in a ratio of 10:8:5. So from the 5,750, we need to work out the amount of PRSI, USC, and pension contributions that she will pay. So it's basically a ratios question, and to use our ratios, we need to add them together, 10 plus 8 plus 5, so that's my first step. That's getting me 23. So Joanne's wages, or her taxes here, are going to be broken into 23 portions. I'm then going to divide the 5,750 by the 23. And that's going to get me the value of one portion. So 5,750 divided by 23 is 250 euro. So now I'm going to do all three out. I'm going to do PRSI. I'm then going to do USC. And then I'm going to do pension. And for each one of them, I'm going to be multiplying the 250 euro. And for the PRSI, I'm going to be multiplying it by 10 because that's what the question is telling me. The PRSI is the 10 portion of the ratio. I'll then be multiplying the USC by the 8. That's the middle value. And the pension is the final part, which is 5. So I just need to do out these three sums to get their values. So 250 multiplied by 10 is getting me 2,500. So that's my PRSI. So I'll put that in here. My USC is 250 multiplied by 8, which is 2,000 euro. And my pensions is 250 multiplied by 5, which is 1,250. A good way of always checking if you're right, just out to the side of my exam paper here, I would add those three figures together. And if you add them together, you should get back to the tax question, or the tax that they've given to us in the question. And we're back to the 5,750 euro. So that's that figure here, and it's just good practice to add them up to check. Okay, so that's the question 2B, or sorry, 3B. The final part of that question then is asking us to work out Joanne's net pay. So in order to do that, I first of all need to add up all her taxes. So my first tax from 3A was her income tax, and I got an answer of 15,395. I'm then adding on my taxes from B, which is 5,750. I'm going to add them together, and I'm getting a total tax bill of 21,145. So that's all of her taxes. The question though wants her net pay, how much Joanne actually gets to keep. So again, I'm going back to the top of the question, and it tells us that Joanne is earning 65,000 euro per year. So that's her income. I'm now going to subtract her taxes, which is 21,145 euro. And when I take them away, I'm getting €43,855, and that is Joanne's net pay. Basically, how much Joanne gets to keep. That's the end of question 3. Moving on now to question 4. Question 4a. Solve the following inequality and show the solution on the number line below. So the inequality is 5x minus 7 less than or equal to 18. The XER just tells us that x is an element of real numbers, so x is a real number. I'm going to add 7 to both sides, so in other words I'm moving over this minus 7, and that will become a plus when I move it over my inequality sign. So that's leaving me with 5x is less than or equal to 18 plus 7. So that's the same as 5x less than or equal to 25. In order to get x on its own, I'm dividing both sides by 5. So 25 divided by 5 is 5. So x is less than or equal to 5. Don't change the direction of an inequality sign. You only change the direction of the inequality sign when you're dividing by a negative. So don't change the direction of your inequality sign here. Okay, so x is less than or equal to 5. I now need to graph that on my number line. It's telling me real numbers, so my first real number is equal to 5, so I'm drawing a solid dot on 5, and my number line must include every single number less than 5. So in order to account for all those numbers, I'm drawing a solid line on my number line. So that includes the 1s, the 0s, the -1s, the -3s, the -3.5s, the 2.75s. It includes everything. So there's infinite amount of dots on that line. And that's the answer to question 4a. Part B, factorize the following. So I'm going to factorize this by group. So I'm going to take the first 2 parts, and then I'm going to take the second 2 parts. So looking at the parts in green, what's common to 2RS and 4RT? Well, first of all, I can take out a 2, because 2 divides into 2 and 2 divides into 4. I'm also going to take out the OR, because it's common to both. So I then need to figure out, what do I multiply 2OR by to get back to what I had in green? So 2OR by 1S will bring me back to 2RS. I then put in my minus, and then 2 by 2 would get 4, and then OR by T would get back to 4RT. So that's the first part. Second part is the 6T plus 3S. Don't worry about the signs just yet. Look at something that's common. So I'm going to start by taking out a 3. That's what's common. And then 3 by 2 will get me to 6T. And then I need to multiply 3 by 1 to get to 3S. So like I said, don't worry about the signs just yet. So I've taken out the 3, so 3 by 2t is 6t, and 3 by 1s is 3s. You now have to worry about the signs. You need to get this bracket to look exactly like this bracket here. So I have the 1s and I have the 2t, but I don't have the signs. The sign that has to go in front of this 1s here must be a positive, because it's a positive in the other bracket. So I'm going to put a plus here. The sign then that's in front of the t is a plus here, but I have a negative in the original bracket, so I need to put a negative in this second bracket. So now you have to think to yourself, what sign goes out here? So if we put in a minus here, a minus multiplied into that bracket would give me a positive 6t. I don't want a positive, I want a negative. So that means that that outside symbol must become a plus, because a plus 3 by a minus 2 will get me a minus 6. And then if we check the other jump, a plus 3 by a plus 1s will give me this positive 3s. So now I have both brackets looking the same. They're just in a different order, but they still have the same numbers and they still have the same signs. I then need to finish up and put them back together. So I'm putting the 2 that are outside together, the 2r plus the 3 in its own bracket, and then I'm going to rewrite the bracket that I already have, which is 1s minus 2t. That's the same as, so we can rewrite that as well, as 2r plus 3 times minus 2t plus 1s. It's the same thing, but both answers are acceptable. So that's grouping. Part C was a tricky enough difference of 2 squares, perhaps. I'm sure you can probably spot the difference of 2 squares here because there's squares and a negative. But first of all, notice that there's something common to both of them. Both of them are divisible by 5. So I'm going to first of all factorize out the 5. So that can become 5 multiplied by a squared minus 25b, because if I multiply in that 5, I get back to where I was. Now I'm going to look at the difference of two squares, because I couldn't have done the difference of two squares with a 5 and a 125. There's nothing that multiplies by itself to get those numbers. So I'm going to keep this 5 outside the large bracket, and then my difference of two squares tells me to do one with a plus and one with a minus. And the values that are going in are a, because a by a is a squared. Then I need to figure out what gets me to 25b squared. Well, 25b squared is the same as 5b multiplied by 5b. So that's the value that I'm putting into the bracket. So that's going to give me a plus 5b, a minus 5b. Then I'm just going to close that large bracket. So that's your final answer there. 5 multiplied by a plus 5b times a minus 5b. Don't worry if you don't have the square blue brackets around it, but that's your acceptable answer there. That's the end of question 4 then, so we'll scroll down on to question 5. Okay, question 5, a little bit of a problem solver here. In the diagram shown, the length of the side of the square is x centimeters, again, where x is a real number. There's the picture of our square and one side is marked x. Find the length of the diagonal of the square in terms of x. So let's first of all fill in some more information about the diagram. So the diagram is a square, which means all sides are equal. So I'm going to label every side on my picture. The question then said to find the length of the diagonal. The diagonal is a line which goes from a corner to the opposite lower corner. So from top to bottom as corners. I'm then going to pick one of the triangles in that shape. So I'm going to examine this triangle here. It doesn't matter if you take the top one or the bottom one, but I'm going to basically sketch that out again. And I'm trying to find the diagonal of that shape. And the diagonal of the shape I'll just call length D. D for diagonal. Because it's a square, I have angles in here which are 90 degrees. And if we want to find the length of a missing side of a right angle triangle, we can always use our Pythagoras theorem. And our Pythagoras theorem is c squared is equal to a squared plus b squared. That's taken from our log tables. The c is always the side that's opposite the 90 degree across here. So I'm just going to put a little c beside the d. Don't mix up all these letters. That d just stands for diagonal. Then my x and my x are the other two sides in the shape, which are now going to be called a and b. You don't worry which one is A and which one is B. The main one you have to get right is the C, which is across from the 90 degree. So filling in my Pythagoras theorem, my C will now change to a D squared. My A will change to an X squared. And my B will change to an X squared as well. So that'll give me D squared is equal to, well, X squared plus X squared gives me 2X squareds. And I want to get D on its own, so I need to get the square root of 2X squared in the square root. And that's our diagonal. You can go a little bit further if you want. You can break that up into the square root of 2 times the square root of x squared from our log tables. And the square root of x squared, a square will cancel with the square root. So that'll just give me square root of 2 times x, which is the same as if we multiply the x to the front, x times the square root of 2. So they're basically the same thing. I've just taken out the x squared and did my square root on that. Don't forget to put in your centimeters because our units here are in centimeters. Question 6. Emma makes bracelets and necklaces using multicolored beads of different sizes. A bracelet consists of a total of n beads and a necklace has 56 more beads than the bracelet. Write an expression for the total number of beads used to make a bracelet and a necklace. So let's break this up. Let's start off with the bracelet. And we want to write an expression for the amount of beads in a bracelet. And they tell us in the question, a bracelet is made up of n beads. So I just have my expression as n. So if you tell me there's 12 beads in a bracelet, my n is 12. That's basically all that is. The next one they want me to look at then is my necklace. And now we need to look at what's in a necklace. It tells us a necklace has 56 more beads than the bracelet. So more just means to add it on. So I'm going to go n and then plus 56. So if you, again, tell me my bracelet has 2 beads, my necklace has 56 more than that, so 2 plus 56 would give me how many in the necklace. The question, though, wants us to write an expression for the total number of beads. So total number of beads basically just means to add my 2 answers together. So I need to add my bracelet, and then I need to go plus my necklace, n plus 56. And then if I add the 2 n's together, I'll get 2n, so it's 1n plus n, and then I'll add my 56. So the expression for the total number would be 2n plus 56. Looking at part B, Emma uses 100 beads to make a bracelet and a necklace. Find the number of beads used to make the bracelet. So we're using 100 beads in total. So I have my bracelet and my necklace. So I need to find my expression for this, and I have it here. So that is 2n plus 56. And it's telling me that I use up 100 beads. So that must equal 100. So whatever the total amount is, it must be 100. I then need to solve for n here. So I'm going to do an equation. And I'm going to, first of all, subtract 56 from both sides. So that'll give me 2n is equal to 100 minus 56. And 100 take away 56 is 44. And then to get n on its own, I need to divide both sides by 2, which is giving me n as 22. And they wanted me to find the number of beads to make a bracelet, and the bracelet was n, so therefore there's 22 beads in a bracelet. Okay, that's question 6. Question 7, a function is defined as 2x squared minus x minus 6, where x is an element of the real numbers. Part A, write down the 2 factors of the function f of x. So f of x is just the name of the function. So we're looking for 2 brackets here. I'm going to first of all multiply the number in front of the x squared by the constant. So that's giving me 12. So I'll just write out my function here again, 2x squared minus x minus 6. So multiplying the number in front of the x squared by the constant, which is minus 6, gives me minus 12. I'm then going to look for the factors of minus 12 that add up to the number in front of the x. Now the number in front of the x is a minus 1. They don't show the 1, but we know it's minus 1. So the factors of minus 12 are 12 and 1. That won't make 1. 6 and 2 won't make 1. But I have 4 and 3. So I'm going to write down my 4 multiplied by my 3. Now the signs are important. I need to get to a negative 1 when they are added and minus 12 when they're multiplied. So one of these must be a minus, so it must be the 4, and then the 3 must be a positive. So minus 4 by positive 3 is minus 12, and minus 4 plus 3 is negative 1. So I'm now going to rewrite my function, 2x squared, and I'm now going to insert my 2 factors as my replacement for minus 1x. So that becomes minus 4x plus 3x, and then take away my minus 6. So still minus 4x plus 3x still gets me back to minus 1x. I'm then going to factorize the first 2 and then factorize the second 2. So I'm going to factorize out 2x bracket x minus 2. And then in the second one, I'm going to factorize out a positive 3, and that'll be multiplied by x minus 2. So you can see here now I have one of the brackets already done because I have x minus 2 common. So just to finish off the second one, I'm putting the 2x and the plus 3 together. So write down the 2 factors. The 2 factors are 2x plus 3, x take 1. Or sorry, x take 2. Part B then wants us to solve those factors. So I'm going to basically rewrite what we have. So my function is 2x squared minus x minus 6. And they want me to solve that when it is equal to 0. I have my factors, which are 2x plus 3 multiplied by x minus 2. And again, I need to solve those equal to 0. I'm going to take both of them separately. So I'm just drawing a little line down the middle, and I'm going to take the 2x plus 3 and let it equal to 0. And then I'm going to take the x minus 2 and let that equal to 0. I'm then going to solve both of those. So with the first one, I'm going to subtract 3 from both sides or move over the 3. So that becomes 2x is equal to negative 3. So dividing across by 2, I get x is equal to minus 3 over 2, which is the same as minus 1.5. And on the second one, I'm adding 2 to both sides, or moving it over, which will give me x is equal to positive 2. So that's part B. They're my solutions there, or my roots. X is equal to 2, and x is equal to minus 3 over 2. Part C, draw the graph of the function in the domain minus 2 to 2 on the coordinate graph opposite. So it's on the next page here. So it wants us to show all of our workings. So we're going to basically do out a table for all of our values within our domain. So let's just draw out a table and see what we have here. So the domain is my input. So I'm going to call that my x, what's going in. And my y will be my output. So let's look at our x's. So I have minus 2, minus 1, 0, 1, 2. So I'm going to start with minus 2, minus 1, 0, 1, 2. All the numbers from minus 2 to 2 basically. You can go up in halves if you wish. I'm going to stick to just the whole numbers. My next line is then going to be my function. My function here is 2x squared minus x minus 6. So I'm basically putting the values into that function. That's my next step here. So let me just draw another line across here just to make it a little bit tidier. Haven't left myself actually maybe enough room. But for the first one here, let's do out minus 2. So what you're doing here is you're basically subbing in minus 2 for x. So if I rewrite my function here, it'll be 2 bracket something squared minus bracket minus 6. So I'm putting in the minus 2 in here. And when I work that out, I'm getting my output, or my y value. So let me just draw another line here. This will give me my output, which is going to be, when I sub in minus 2, I'm getting 4. And I continue that process. What happens when I put in minus 1? So I'm going 2 times minus 1 squared minus minus 1, and then take away the 6. And that's giving me a minus 3. I'll do out one more here. We'll do out the value for 2. So that's going to be 2 bracket something squared minus my x minus my 6. And this time I'm putting 2 in for x. And when I work that out on my calculator, I'm getting 0. And I'm going to fill in my remaining ones. I have a minus 6 and a negative 5. So they're my inputs for x, outputs for y. So my points now, all the coordinates that I'm going to plot. My first one is minus 2, 4. My second one is minus 1, minus 3. My third coordinate is 0, minus 6. My fourth coordinate, 1, take 5. And my final coordinate is 2, 0. So the x always comes first, followed by the y. Going to move that over now onto the next page and sketch my function. My function here is going to be a quadratic equation, so it's going to look like a curve. My first point is minus 2, 4, which will be here. My second one, minus 1, minus 3, which is down into this quadrant. My third one is 0, minus 6, which is on the y-axis. My next one is 1, minus 5, which is here. And my final one is 2, 0, which is on the x-axis. I now need to sketch the function. So it's a freehand curve. Don't use a ruler when you're sketching a quadratic. And it would look something like that. So that's my quadratic equation sketched. And now looking at part D to that question. It's asking us to use the graph to show that your answers on part B are correct. So first thing I'm going to do is then just going to go back and take my answers from part B. My answers for part B were x is equal to minus 1.5. And I also got x is equal to positive 2. And I now need to use my graph to show that they're correct. So looking at my graph, I'm on my x-axis and going back to minus 1.5. So that looks correct to me. And I'm then going up to positive 2, which is here. So that looks correct to me as well. So it's basically where they cross the x-axis. So I'm basically going to just state that. So my points are where they intersect the x-axis. And I have them marked on my diagram as well, on my sketch. and I'll just write in where x is equal to minus 1.5 and x is equal to positive 2. The final part to that question is part E, and it's asking us on the graph, show the axis of symmetry of the function and write down the equation of this axis of symmetry below. So just remember what an axis of symmetry is. An axis of symmetry is like the butterfly effect, that you can fold it over onto itself and it's going to map itself. It's going to be the mirror image of each other. So think of a rectangle first of all. So this shape here has an axis of symmetry down the middle here, that if I was to fold that shape over, it would fit nicely onto itself. So that's what axis of symmetry is. So I need to figure out the axis of symmetry for my quadratic function here. So the axis of symmetry is going to be through the point where the curve is at its lowest. So it's down around this point here. So my axis of symmetry is going to be a line that goes through that point. So along that red line. So if I was to fold my quadratic equation over that red line, it would map onto itself. So that's my axis of symmetry drawn onto the curve. Now I need to figure out what is the equation of that line. So if I draw a dot here where it crosses the x-axis. Now where does that cross the x-axis? It looks somewhere around maybe positive 0.3. And it's crossing the x-axis. So I'm going to say x is equal to 0.3. So basically what that means is everywhere on that line, x is going to be 0.3. So if I was just to pick a random point, pick it here where I've drawn that blue dot. The coordinates of that blue dot are 0.3 up to 4. So that's why we're calling it x is equal to 0.3. And that's the equation basically of my axis of symmetry. So filling that into my final answer, I'm going to, on your graph, I've done that, and then it says down here, write in the equation, x is equal to positive 0.3. Question 8. Rugby goalposts are fitted with foam protectors as shown to protect each player from injury. Each protector is in the shape of a cuboid that has a cylindrical section removed from its centre where the goalpost fits. The cuboid has a square face that measures 300 millimeters by 300 millimeters, and it is 1.8 meters in length. The cylindrical section has a diameter of 150 millimeters and is also 1.8 meters in length. Part A. Find the volume of foam in one of these protectors. Give your answer in meters cubed, corrected 2 decimal places. Okay, so a lot of information there to take from it. Let's first of all sketch out one of our foam protectors, just to see what we're looking at here. So we have our face of our foam protector, and the foam protector is 1.8 meters in height. So from top to bottom, it's 1.8 meters in height. Question then tells us that the face of it is 300 millimeters by 300 millimeters. Now 300 millimeters is 0.3 meters if we divide by 100. So I'm turning them all into meters. It's 1.8 meters high, 0.3 meters thick and 0.3 meters wide. It then has a cylindrical hole cut out of the shape, something like that. And it then tells us that that cylindrical hole is 150 meters in diameter. So 150 millimeters in diameter is the same as 0.15 meters in diameter. So that's everything we know. So let's first of all find the volume of the entire shape. So just imagine that the cylindrical hole is not in the shape. So I'm going to get the volume of the box. So the volume is found by multiplying length by width by height. And that is going to give me a volume of my length, which is 0.3, width of 0.3, and a height of 1.8 meters. When I multiply those three by each other, I'm getting a total volume of 0.162 meters cubed. But the object, or the foam protector, has this cylinder cut out of it, and the cylinder has a volume which is found from our log tables with the formula pi r squared h. That's the formula for finding the volume of a cylinder. So working that out, I have volume is equal to pi, I'm going to use the button on my calculator, multiplied by the radius. Now the radius is found over here, so I have the diameter, which is 150 millimeters, so I need to divide that by 2. So 0.15 meters divided by 2 will give me the radius of this shape, and that is giving me a radius of dividing it by 2 of 0.075 as a meter. And then I multiply that, or square that, and then I multiply by the height of the shape, which is 1.8 meters. So working that out on my calculator is giving me roughly 0.0318 meters cubed. That's the volume of the cylinder cut out of it. But the final part now is to get the total volume of foam. I need to take the volume of the full object minus the volume of the cylinder. So that's going to be 0.162 meters cubed, subtract 0.0318 meters cubed, and that is going to then give me the new volume of the shape, which is to 2 decimal points, 0.13 meters cubed. Okay, so that's part A done. Looking at part B. A foam protector is covered with PVC material to make it waterproof. Find the total surface area of the protector, which is covered by the PVC material. Give your answer in meters squared. Okay, so we basically need to find the total area of this shape. So I need to basically get the area of the front of it, the back of it, the 2 sides, the bottom, the top, and then the cylinder in the middle. So looking at a protector here, first thing I'm going to do is find the area of the front of the protector. So I'm just going to do out my front first. And the area is found by multiplying length by width. So this is my front, I'll call it part 1. That's this area in here. And length by width, so the length of the shape is 0.3 and the height of the shape is 1.8. That's the height of it. So this length here is 1.8 meters and the width of it is 0.3. And I multiply them out on my calculator to get 0.54 meters. Okay, that's the first part. Number 2 is going to be the back of the protector. The back of the protector is going to be looking in from back here. So that's going to be area 2, which is basically going to be the same as the area of the front. So I'm going to go area is equal to 0.54 meters. It's the same as the front. And then I have area 3, which is going to be the side of the protector. And that's going to be this area here. And once again, it's the same area as the front. So area is equal to 0.54 meters. I'm then going to take the other side of the shape, which will be in from here. So that's area 4 looking in, which is going to be the other side, which again is giving me the exact same area of length by width of 0.54 meters. Okay, so that's basically the sides of the protector done. Next thing I need to do is look at the top of the protector, this area here. So first of all, forget about the circle on the top. So imagine the circle wasn't there. So we'd need to get the area of the full square. So the area of top, I'll call it. So this is going to be my 5th area. So top, I'll call it. So that's looking down onto the shape. So that's going to be an area of length by width, which is going to be 0.3 by 0.3, which is giving me an area of 0.09 meters squared. Sorry, these are all in squareds. Sorry, I have them as meters. I then need to take away, so I now need to remove the circle from that shape. So minus the circle at the top. And the area of that circle is going to be found by using our area formula. And the area of a circle is found by pi r squared, which is going to be pi button on my calculator. The radius we have from part A up above, the radius of that circle is 0.075 and I have to square it. So That's giving me the area of the circle as 0.0177. So I now need to, so I'll just go, therefore I need to take away that circle from the top of the shape. So 0.09 minus 0.0177. So I'm removing the circle, which is giving me 0.09 subtract 0.0177 to give me 0.0723. So that's the area of the top of the shape. Now I also have that shape on the bottom of the protector, so looking in from the base. So that's going to give me the exact same area. So this is, I'm going to call the bottom. And it has the same area, which is going to be 0.0723. Now I have one more area to find, and it is the cylinder within the shape. So imagine you're looking through a straw. You're now looking for the area of that curved part as you look through the cylinder. Imagine, as I said, you're looking through a straw. The area of a cylinder is found again from our log tables, and the area is found by 2 pi or h. So that's the formula for getting the area of that curved part. So filling that in, I have 2 multiplied by pi multiplied by radius 0.075 multiplied by the height of the cylinder 1.8. That's getting me a total area for the cylinder of 0.848 meters squared. So nearly there. Final step to get the total area. And the total area of the PVC is found by adding up all of our answers there, all of our areas. So area 1, 0.54, area 2, 0.54, area 3, 0.54, area 4, 0.54, the top of the box, 0.0723, the bottom of the protector, 0.0723, the cylinder down the middle of the shape, 0.848 meters squared. Adding them together is going to get me the area, and the question wants it to 2 decimal places. 3.15 meters squared. So that's the total surface area of the protector. Question 9a, a 6-shape repeating pattern which continues indefinitely is shown below. Indefinitely just means it continues forever. And it has pattern 1, pattern 2, pattern 3, 4, 5 and 6. Part 1, work out the shape of pattern 20. Well, different ways you can do it. You can continue drawing out all of the patterns until you get to number 20, but you can also just use your use of patterns here. So this shape repeats itself after 6 goes. So my pattern 7 here is going to be the first one again, the square with the little dot on it. So what I could do there is I could just take the number 20, pattern 20 that they want, divide that by 6, which will give me 3 point, and then it'll give me a remainder. So if you go to your calculator and go 20 divided by 6, it'll give you 3.33. But what we want to look at is that if you divide 6 into 20, it goes 6, 12, 18 with a remainder of 2. So I'm looking for what's left over here. And that remainder will tell me how many places I now need to go up. So I need to go up 2 places. So there's 1, 2. So in other words, the 20th pattern is going to be the same as pattern number 2, which is going to be the star. And again, we don't need to draw the star. It just has to be labeled as pattern 2. But that's how we find the shape of pattern 20. Same steps can help us to find pattern 2021. I take the total 2021, I divide it by 6. Dividing it by 6 is 2021 divided by 6 on my calculator. I get 336 0.8. Now I need to figure out what that 0.8 means for my remainder. So what I'm going to do is I'm basically first of all going to take the 336, multiply it by 6, and it'll get me to 2016. So if I'm at 2016, that means I now have a remainder of 5 because I have to get from 16 to 21. So remainder 5 here. I then count my 5 places. So pattern 1, 2, 3, 4, 5. So that means that my 2021st pattern is going to be the same as pattern number 5, which is the diagonal with the little square in the middle. Looking at part B, in a particular exponential sequence, the first term is 3, the fourth term is 81. Fill in the boxes below to show the first 5 terms of the sequence. An exponential function is one which is going up by a power, so you need to figure out what it's going up by. So as we look at it here, if I take the 3 and I take the 81, so let's start with the 3, that could be 3 to the power of 1. Then I have to figure out 3 to the power of what is 81. And that's 3 to the power of 4. And let's just see if that continues. So what happens if I go 3 to the power of 2? That's going to give me a 9. 3 to the power of 3 would give me 3 by 3 by 3, which is 27. We have the 81, which is 3 by 3 by 3 by 3, which is 81. And then my fifth one will be 3 to the power of 5, which is giving me 3 by itself 5 times, which is 243. B part 2, show that 6561 is a term of this sequence if the pattern continues. Hint to use the square root button. Okay, so let's use their hint. They're telling me to get the square root of 6561, which is 81. Now don't forget that a square root means that you're squaring it. So in other words, that's the same as going 6561, which is the same as 81 squared. So pause this and have a look and check that for yourself. 81 squared will get me back to 6561. But what they want me to spot is, look what we have from B part 1. We know that 81 is the same as 3 to the power of 4. So I'm going to change that 81 to 3 to the power of 4. So 6561 is equal to 3 to the power of 4, but it also has that squared on it. So I need to square that now. I'm then going to go to my log tables on page 21, and you can see here the third rule down, a to the power of p to the power of q. That's what I have now. So in order to deal with my powers, p and q, I need to multiply them, p multiplied by q. So that's what I'm going to do here. So my final answer there will be 6561 is equal to 3 to the power of 4 by 2, which is 8. And there's my sequence continuing, because we have 3 to the power of 1, 3 to the power of 2, 3 to the power of 3, 3 to the power of 4, 3 to the power of 5, and now I have my new one, which will be 3 to the power of 8. So you can see here that it's continuing with the same large number, the 3, and it's increasing by a power each time. Question 10a, Brian makes the following statement. If a 2D shape is a square, then it must have 4 sides of equal length. Complete the converse of Brian's statement. Well, if a 2D shape has 4 sides of equal length, then it must be a square. Okay, so that's basically our part 1. So we'll repeat that there. If a 2D shape has 4 sides of equal length, then it must be a square. Part 2. Is this converse of Brian's statement true or false? Put a tick in the correct box to show your answer. Tick only one of the boxes. So I'm going to tick false for this, because if you think about it, looking back on Brian's statement here, if a 2D shape is a square, then it must have 4 sides of equal length. Well, that's fine, because a square has to have 4 lengths. But look at our new statement here. A 2D shape that has 4 sides, and I'm stating that that must be a square. Well, that's not necessarily true, because let's draw one out. So I have a 2D shape, 4 sides of equal length. Well, there's one side, there's my second side, there's my third side, and there's my fourth side. Not the best. Let me redo that. So I have one side, 2 sides, 3 sides, and my fourth side. They're all equal length, but am I now creating a square? I'm not. A square has to have all 90-degree angles, which this shape doesn't. The shape that I've drawn is now known as a rhombus. So that's why I'm ticking the false box here. So I'm just going to say a rhombus is also a 2D 4-sided shape with sides of equal length. So there's my solution there. So put a tick in the box to show if it's true or false. I've said it's false because a 4-sided shape of equal lengths could also be a rhombus. It doesn't have to be necessarily a square. Part B, 2 squares are shown in the diagram. The larger square has sides of 5x, so it's a square. So I'm going to fill in all 4 sides here. I have 5x, 5x, and 5x. And the smaller square has an area equal to 1/9 the area of the larger square. Okay, so we're talking area here. So first of all, I need to find the area of that larger square. So the area is found by length by width, which is going to be the length of the shape, which is 5x, multiplied by the width of the shape, which is also 5x. So the area of the large shape is 5x by 5x, which is 25x squared. It's then telling me that the area of the smaller shape is 1/9 the area of the larger shape. So I basically just need to find 1/9 of 25x squared. So find 1/9 of 25x squared. Now to find 1/9 of something, we basically multiply it by 1/9 or divide by 9 and multiply by 1. So technically all I need to do here is go 25x squared divided by 9. Or I'm going to do it separately here. It's the same as 1/9 multiplied by 25x squared, which would give me, write them as fractions and top by top, bottom by bottom. So 25 over 9x squared is going to be the area of the smaller shape. But reading the question again, the question wants us to find the length of the sides of the smaller square. So if we make up a basic example here, so I have a square and I tell you that the area of it is 16. In order to get the lengths of the sides of that square, I get the square root of 16, which is 4. So that gives me the sides of 4. So another example there could be if the area is 49, in order to get the lengths of the sides, I go square root of 49, which is 7. So I have 7 and 7 here, so 7 by 7 is 49. So I'm basically getting the square root of the area. So that means to get the length of a side, I'm taking the square root of 25x squared over 9. Now notice how they don't want the square root in it. So all I have to do is get the square root of all of these dimensions. So the square root of 25 is 5. The square root of the 9 is 3. And the square root of x squared, well, we know that a square cancels with a square root. So that just gives me the x. So the square root of the 25 is 5. Square root of x squared is x. And the square root of 9 is 3. So the length of a side is 5x over 3. Now we're not told whether it's centimeters or meters or kilometers, so I'm just going to call it units. And that's question 10 finished. Question 11. 2 perpendicular lines M and M pass through the point 2, 3. The equation of M is y is equal to 3x plus 4. Write down the y-intercept and the slope of the line M. So in order to do this, we're going to use our log tables and take the form of the equation of the line as y is equal to mx plus c. And the equation I have is y is equal to 3x plus 4. Now the c stands for the constant, and that tells you where the point crosses where the line crosses the y-intercept. And it's crossing the y-intercept at 4. The slope is given by the letter in front of the x. M stands for slope. So the m is 3 in this equation, so the slope of our line m is 3. Part B, find the equation of the line n. Give your answer in the form ax plus by plus c is equal to 0. Now n is perpendicular to the line m, so if two lines are perpendicular to each other, it means they meet at right angles. And the slope of the equation m, so let's just call this one m, and its slope is 3. So in order to get the perpendicular slope of the line n, I need to flip the fraction and change the sign. So the slope of m is 3 over 1. Flip it, it becomes 1 over 3, and I make it a minus fraction because I changed the sign. So that's my slope for the line n. The point on that line is the same point. It's 2, 3, because the question tells us that the point 2, 3 passes through the line n and m. So again, from my log tables, the equation of the line is given by y minus y1 is equal to m times x minus x1. M stands for slope, so that's my minus 1 over 3. And then filling in my x1, it's going to be 2, it's coming from my point 2, 3, x1, y1, so that's 2. And filling in my y1, it's going to be positive 3. So y minus 3 is equal to minus a third times x minus 2. I just need to multiply in that third. You can get your common denominator as 3, multiply across by 3. A quick way of doing it is if you multiply this 3 up to the two numbers on the left hand side of the equals, and then multiply the minus 1 to the two numbers on the right hand side. So that's what I'm going to do. So 3 multiplied by y is 3y. 3 multiplied by minus 3 is minus 9, is equal then to minus 1 times x minus 2. If I multiply in that minus 1, I get 3y minus 9 is equal to minus 1x. Minus by minus gives me a plus 2. Now just look back at the question. The question wants it in the form x, y number. So I just need to rearrange the order of my equation here. So I'm going to move everything over to the right, or sorry, to the left hand side of the equal sign. So that's going to finish off with 3y minus 9. Moving over to minus 1x becomes a plus 1x. And moving over to plus 2 becomes a negative 2. I can put the minus 9 and the minus 2 together, which is going to give me 3y plus 1x minus 11 is equal to 0. And again, looking at the question, they want the x to come first. So that's the same as 1x plus 3y minus 11 is equal to 0. The final part of that question, part C, is asking us the point minus 1, 4 is on one of the lines, m or n. Which line is it on, and justify your answer. So if a point sits on a line, in order to prove that, we sub the point in for x and y, and you should get your answer to be 0. So what I'm going to do here is I'm going to take two scenarios. I'm going to take the line m, and then I'm going to take the line n, and I'm going to sub in the point into both of those lines. So the line m we have as y is equal to 3x plus 4, and the line n I found in part B to be 1x plus 3y minus 11 is equal to 0. I'm going to then take my coordinate. My coordinate is minus 1, 4, and I'm going to do it to both of them. And I'm going to sub in the minus 1 as x, and I'm going to sub in 4 as y. And like I said, when you sub it in, one of these should give me 0 is equal to 0. So subbing it into m first of all. So I get y, which is going to be 4, is equal to 3x, so 3 times minus 1, plus 4. So that gives me 4 is equal to minus 3 plus 4, and 4 is equal to positive 1. But 4 cannot equal to negative 1, or sorry, positive 1. So therefore, the point does not sit on m. Let's check now with n and see does it sit on it. So subbing in minus 1 for x, subbing in 4 for y. Let's see, does this equal to 0? So 1 times minus 1 is minus 1. 3 times 4 is 12, minus 11 is equal to 0. Minus 1 minus 11 is minus 12, and minus 12 plus 12 is 0. So 0 is equal to 0. So since equal, it sits on the line n. So my answer here is going to be n. So in order to show a point sits on a line or on a curve, it must satisfy the equation. So you sub it in and you're hoping to get 0 is equal to 0. Question 12, a triangle ABC has a right angle in it. So let's draw out this triangle. And it tells us that BC is equal to 12. And it's telling us here in the question that the B is the angle in the middle and it's the right angle. So this must be my angle B here, where the right angle is. BC is equal to 12. And they want us to work out AB, the perpendicular height. So the height is going from A to B. So this must be my A up here. And then my C over here. And the length from B to C is 12. And then they tell me that the area of this triangle is 48 centimeters squared. Now we know that the area of a triangle is found by multiplying the half, the base, by the perpendicular height. That's how we get the area. So filling all that in, we have 48 as my area, half times my base, which is 12, and multiply that by h. Well, that's what I need to find. I'm trying to find the height, or AB in this case, on this triangle. So half of 12 is giving me 6, is equal to 48, and 6 by h is giving me 6h. So to get h on its own, I'm dividing across by 6. So 48 divided by 6 will give me the perpendicular height of this triangle. So that gives me a height of 8 centimeters. 48 divided by 6 is 8. So part B, construct a triangle ABC in the space below. Clearly show all of your construction lines. So I've just used my ruler and my compass to construct these two lines intersecting at 90 degrees. And I'm also using my set square to create that 90 degree. Label the corners as according to the first part of the question. So this will be my B, this will be my C, and I have my A up the top, the perpendicular height. Fill in the dimensions. We have 12 centimeters here, and we have the perpendicular height of 8 centimeters. So use your ruler to measure these. I'm then going to get my ruler and connect A to C then. And I've created the triangle then ABC. Just make sure in this question to use your ruler to get the correct lengths, the 8 and the 12. Use your set square to create the 90 degree at B, and show all of your work. So when you've measured the length of the line, just put that arc with your compass to show your workings. Part C. On your diagram, measure the angle of BCA. BCA is this angle in here. This is the size of the angle that they want me to measure. And in order to measure it, I'm going to use my protractor. So the protractor is the half circle shape in your math set. And I'm getting an angle of roughly 33 to 35 degrees. So somewhere around 34 degrees. But they'll give you a margin of error there. So somewhere between about 33 and 35 degrees should be fine. Use trigonometric ratios to verify this answer. So your trigonometric ratios are your sine, cos, and tan. So I'm just going to write them out here. So you have sine A. So that's silly old Harry. And then I have my cos, caught a herring, tan, trawling off America. So that's my opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Just re-sketching my triangle again. I have 8, 12, and the 90 degree. And they're trying to get us to measure the size of the angle C again, which is this angle in here. So I'm just again going to label my triangle. So the side across from a 90 degree is always called the hypotenuse. The side across from the angle that you're trying to find is known as the opposite. And then the third remaining side is the adjacent. So as I look at my picture here, I have 12, which is adjacent, and I have 8, which is opposite. So I'm using opposite and adjacent. Opposite and adjacent is using tan. So I need to use the tan ratio, which is tan angle is equal to opposite over adjacent. Now tan angle I'm going to change the name of my angle. It's called C in my picture, so I'm just changing that to tan C, is equal to opposite, which is 8, over adjacent, which is 12. I'm then going to my calculator, and I'm basically going to turn 8 over 12 into 2 over 3. So that is tan C. I then need to move the tan over the equal sign. So when I move this tan over, I get C is equal to tan inverse. So we put that little minus above the tan when I move it over the equal. So tan inverse of 2 over 3. I then go to my calculator and I press the shift button, then the tan button to get that tan inverse button. And then I type in the 2 over 3. And that's getting me roughly 33.7 degrees. And the question said to verify it to part C, which was to the nearest degree. So I'm going to 34 degrees. So I've verified my answer. Question 13. In an archery competition, Liam shoots 72 arrows, hitting the target shown each time. Liam's scores are displayed in the frequency table below. Part A. Find X, the number of times Liam hit the bullseye, 10-point zone of the target. So we know that Liam hit it 72 times, and the frequency basically represents how many times he hit it. So in other words, all of these values must add up to 72. So I have 6 plus 11 plus 9 plus 14 plus 19 plus X must add up to 72. When I add the values, I get 59 plus X, that unknown value, and that's 72. Subtracting 59 from both sides, or moving over to 59, leaves me with X is equal to 72 subtract 59, which gives me an answer for X of 13. So he hit the target 13 times. Part B, write down the modal target score for Liam, i.e. the mode. The mode is the value that appears most often, and that's going to be the target 9, because Liam hit the target 19 times. So the modal value here is 9. Just make sure you don't write down the frequency 19. You'll get attempt marks perhaps for writing down the 19, but the actual answer is the target score, which is the most popular, which is 9. Part C. Find the estimated mean score of a single arrow, giving your answer to the nearest whole number. So because this is a frequency table, it's not just as simple as adding them up and dividing by how many you have. So in order to calculate the mean from a frequency table, we need to take the first score, which is 5, and then multiply it by the amount of times it appears, and it appears 6 times. I then add on the next score, which was a 6, multiplied by the amount of times it appears, and so on. So Liam scored a 7 9 times. He scored an 8 14 times. He scored a 9 19 times. And then finally the bullseye, the number 10, he scored it 13 times, which we found in part A. I then divide that not by 6, but by the total amount of arrows that Liam hit, which is 72 arrows. When I tidy up the top of the fraction, 5 6s are 30, 6 11 66, 7 9 63, 8 14s 112, 9 19s 171, and 10 13s 130, all divided by 72. So here you can see that I'm showing all of my work. Adding up the top line, I get 572 over 72. And the question said, give my answer to the nearest whole number. But when I divide that in, I'm not getting a whole number, I'm getting a decimal. I'm getting 7.94, which rounds to 8 as nearest whole number. So the mean here is 8. Part D to that question, use the values in the table to find the median score. Justify your answer. So the median score is always going to be the middle value. So I'm just going to scroll back up to my table now and figure out which is going to be the middle value. So if you wanted to, you could list out all the values, the 72 of them. But a quicker way of doing it is just think about how many arrows Liam hit. He hit 72 arrows. So if I divide that by 2, I get 36. So I'm looking basically for the middle of 72 numbers. So the middle, it's because it's even, there's going to be the two middles, which is going to be the 36th and the 37th arrows, because that basically means that from 37 up to the 72nd arrow, there would be 35 more arrows, and bringing my 36 down to the original 0 when he started off would have 35 arrows. So the middle there would be 36 to 37. I basically just need to figure out now which is the 36th, 37th arrow. So I go back to my frequency table. So there's the first 6 arrows, then the next 11. So that brings me up to 17 arrows. Add on the next 9 brings me to 26 arrows. And then add on the next 14 would bring me to 40 arrows. So that means that the 36th and 37th are in here. It's in that quantity of 14, and that gives me a median then of 8. So the median value is going to be 8. Perhaps it's easier to list them all out, and then to list them all out you'd have to go 5, 5, 5, 5, 5, because a 5 appears 6 times. You then have to list this number 6 out 11 times, and so on and so on and so on. I'm not going to list them all out, but that's what you'd have to do, and then circle the middle value. So my median is going to be 8. Part E, in your opinion, which one of the measures of center of tendency, so centrals of tendency are basically just mean, mode and median, is the most representative of Liam's score? Give a reason for your answer. So look at, you can accept any one of the 3 as long as you give a justifiable answer. So I could say the mean is the best measure of central tendency, and I could say because it uses all the values, so I've added them all up within the table, and there are no outliers. If there was an outlier, I wouldn't use the mean, because an outlier is that value that's way off different to the rest of them. But I don't see any outliers here, so the mean would be an acceptable measure to use. That's what I'm going to stick with. You could also pick maybe the mode, because the most targets hit was number 9, wasn't it? And that's kind of up around between the 8 and 10, which accounts for about 46 of his arrows, which is roughly, what, 60% of his arrows. So you could mention that if you wished, if you mentioned the mode. So if you mention the mode, you're looking to kind of state why, because it's up around the 8 to 10 arrows, which includes over half of the arrows. But I think the mean is probably the easiest one to go with there. Final part, part F. Complete the pie chart below to show Liam's scores, label each sector and the size of each angle clearly. So a full pie chart is out of 360 degrees, so that's our full circle. Liam has 72 arrows, so I basically just want to find out, first of all, what size angle represents each arrow. So if I divide 360 by 72, I get 5 degrees. So in other words, one arrow is representing 5 degrees on my pie chart. And what do we know? So we have, let's start with each target. So I'm going to start with target 5. So target 5 was hit, was it 6 times? It was. So I could just go 6 arrows multiplied by 5 degrees, which would get me 30 degrees. An alternative way of doing that is you could also take the 6 arrows, put it out of 72 and times it by 360, and you'll also get 30 degrees. Target number 6. Target number 6 was hit 11 times. So I could just go 11 by 5 and get 55 degrees. Target number 7, I'm just going to do this the other way now. I'm going to write it as a fraction. So target number 7 was hit 9 times. So I'm going to go 9 over 72. So this is just the other way of doing it. Multiplied by 360 degrees is giving me 45 degrees. Target number 8 Target 8 was hit 14 times, so 14 out of 72 arrows multiplied by 360 is giving me 70 degrees. Target number 9 then was hit 19 times, so I'm just going to go the other way now of doing it here. So I'm going to go 19 multiplied by 5 degrees, which gives me 95 degrees. And then my final arrow, which is my final target, target 10, which is hit 13 times. That's my value for x. So 13 out of 72 multiplied by 360 degrees is getting 65 degrees. And to check your answer, if you add all of these up together, they should total 360 degrees. So now I just need to put it onto my pie chart. So I don't have a protractor here on the computer, but basically what I would do is, first of all, I draw a line across from the center to the edge. So that's going to be my starting point. I then use my protractor to measure each of these angles. So the first one there is 30 degrees. So you use your protractor, measure out to the angle of 30 degrees. And the question says we need to mark in the size of each sector and what it represents. So it represents target 5. So I'm just going to call it T5. And you work your way around the shape. So I'll do one more. Say, for instance, the 55, which would bring me up to about here. And that's going to be 55 degrees. And it's going to be target number 6. So you just work your way around that shape as best you can, though, with your protractor. As I said, I don't have the protractor here to be able to finish it out.